For lesson 3 of chapter 2, we're going to be solving two-step equations. So we'll do just that at the beginning, then we'll find an input of a function and then solve a multi-step real-world problem too. First, let's solve these two-step equations. We're going to follow pretty much the same format as last time with the one-step equations, except with now the extra step. And when we solve these, we need to work inversely. What I mean by that is the x is being divided by 2 first, then adding 5. When we undo that, get the x by itself, we have to work backwards. So since this happens second, we're going to get rid of this first. So we're going to add -5 to both sides. So that'll be leaving us with x over 2. And then now it's going to be equaling positive 6 because the positive is 1 by 11. Then we'll be multiplying both by 2, which would then cross these out. So x would be equaling 6 times 2, which then we would know x would equal 12. Let's solve this one over here then. We have 4 times y, then minus 4 equals 16. So we would solve this one first, add the opposite, which would be positive 4, and then do that to both sides. So I add 4. So we'd be left with 4y equals 20. Divide both sides by 4 now. So that'd be 1y equaling 20 divided by 4, which would be 5. Here sometimes we have two variables by each other on the same side, and what you really have to do is just simplify this equation first, then solve it. We have positive 7x minus 4x. These are terms that can be combined, so we would do 7 minus 4, which would be 3x, and that would equal 21. And now we can just divide by 3 on both sides. So x would then equal 7. Here we have negative 2x plus 5x equals 9. So which wins? The positives or the negatives? Here the positives win by 3. So we'd be left with 3x equals 9. Divide both sides by 3. And that would be x equals 3 for our answer. Now let's find an input of a function, basically just writing out a two-step equation. The output of a function is 3 less than 5 times the input. So find the input when the output is 17. So if we're going to write this out, output is always y, right? So it's y equals 3 less than 5 times the input. Okay, so it's 5 times the input and then 3 less than that, huh? So it'd be 5 times x, then minus 3. So if we're going to plug in 17 for the output, it would be 17 equals 5 times x minus 3. And then we can solve this. Let's do the add 3 first. Do that to this side too. So we'll be left with 20 equals 5x. Divide both sides by 5. And that would be 4 equals x. Now let's solve a real-world problem. As a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases, and you might know that from experience. The pressure at the surface of the water is 2,117 pounds per square feet. That sounds like a lot, but it's true. That's how much pounds get pushed onto you every square foot of your body. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Find the depth at which the diver experiences a pressure of 8,517 pounds per square foot. So we have to total up to 8,517. So let's find out what that would be. So we're already at 2,117 before we dive, right? So that just gets added on the beginning. So 2,117, what do we add to that then? Well, it's a rate of 64 pounds per square foot. Well, we could put the rate right here, 64, and we're multiplying that times square feet. I'm going to say area, right? A for area. And then we can solve this equation. Well, we're multiplying first, then adding, right? So we need to get rid of this adding. So we would add the opposite, negative 2,117. So if we're going to solve that one, we have positive 8,517. Then pretty much treat this like a minus 2,117. So 8,517 minus 2,117. That's 6,400 pounds. So we have 64A equals 6,400. Divide both sides by 64. And then you'd be left with A equals 6,400 divided by 64 equals 100.